So today we are going to see about the number system. There are four important number systems are available: binary, decimal, octal and hexadecimal. The binary is represented using two digits only, 0 and 1, where the decimal is represented using 10 digits starting from 0 to 9. And the octal numbers are represented using 0 to 7. So the hexadecimal is represented from 0 to 9 and also using the digits A, B, C, D, E and F. The equivalent value of A is 10, likewise for B it is 11, C 12, D 13, E 14, F 15. So the example for each representation is given over here, and if it is a binary it will be represented using 2, if it is decimal it is represented using 10, if it is octal it is represented using 8, and if it is a hexadecimal you will represent using the number system 16. So next thing we are going to see the conversion from one number system to the other number system. So basically the decimal will be converted into all other three forms, that is a binary, octal and hexadecimal. And when we are converting from the decimal to other systems, we have to use the division alone, that's enough. So if it is for binary, divide by 2, the decimal number is divided by 2. If it is octal, divide the decimal number by 8. If it is hexadecimal, divide the decimal number by 16. So the example from decimal to other conversions are given over here. So the division is applied for binary and also to convert to the binary and to octal and hexadecimal. When it comes from decimal to binary, you have to divide it by 2. So the number decimal is 92, which is going to be divided by 2. The quotient will be 46 and the remainder will be 0. So likewise each step we are going to write the quotient and the remainder when you are dividing that by 2. So the 92 is divided by 2, which is the quotient is 46 and the remainder is 0. So likewise we will do until we get 1 or 0. So once we end up with 1 and 0, you can write the binary starting from the end to the top. From the bottom to the top you have to write it in the binary format. So this gives the equivalent binary for the given decimal 92. So the next one, similar way, when you are converting from the decimal to the octal, you have to divide it by 8. So while dividing by 8, you have to write the quotient over here and the remainder over here. So 92 is divided by 8 and the quotient is 11 and the remainder is 4. Likewise you have to do until the number ends up with less than 8. So until then you can continue. So here this 92 is converted into octal and you have to write it from the bottom to the top 1, 3 and 4, which is the octal. Similarly for the hexadecimal, you have to divide the decimal number by 16 and the quotient has to be written over here and the remainder over here. So according to this one, the quotient is 5 and the remainder is 12, where in the hexadecimal after 9 the numbers will be represented as A, B, C, D, E and F. So according to that, the equivalent value for the equivalent representation for 12 is C. So that is why the value is 5C. So for the hexadecimal 92, for decimal 92, the hexadecimal is 5C. So likewise when you are converting from the decimal to other categories, we have to only do the divisions. That is enough for converting from decimal system to other systems.